All right, I'm going to do solving E through H in the work from 6.4.1. There it is right there. All right, so we're looking at this one. We've chosen substitution, right? And that's true because we have this value for D right here. So I'm going to plug in this value for D where I see the D there because D is isolated. So I'll take this equation and I will put it right here. And then where I see the D, instead of putting the D, I will put this value, which is equivalent to the D. It is equal to the D. So there we go. Put that in double parentheses. And then we'll put all of this in red. Some of you may have noticed that this actually has three variables. So now that we've eliminated the D, we still have the T and the W. And truth is, we can't do anything about it. We're just going to get it as far as we can. So we're going to solve this. We're going to first do this distribution. We're going to do 2 times 7, which is 14. So, sorry, it's going to be 3 parentheses, because 3 times 14 plus 2 times W, which is 2W, close parentheses, is equal to, and then we'll do this distribution as well. 15 times T is 15T. Plus 15 times negative W, in other words, negative 15W. All right, we'll continue with this distribution. So 3 times 14 is 42. Don't be afraid to check Desmos. 3 times 2W is 6W. All right, and that will be equal to 15T minus 15W. So what we probably, minus, that's the one I'm looking for. We're going to want to try to get the W's alone. So what I'm going to do is I'm going to add 15 to W to both sides. So we get 42 plus 6W plus 15W is 21W. And that will be equal to just 15T. Then I'll subtract 42 from both sides. So I get 21W is equal to 15T minus 42. And then if I want to get W alone, I'll divide by 21. So W is equal to 15 divided by 21 is 5 over 7. And then minus 42 divided by 21, which is just 2. I'm going to convert this. Oh, and it's 5 over 7T. So I'm going to convert this using Desmos into a decimal. So I just plug it in right there, 5 divided by 7, and it gives me 0.7142857142857. You may notice whenever you divide by 7, you get one of those crazy things. So anyway, I'll copy. I think I copied. And paste. Yep, that's it. All right, cool. So then this is my decimal for T. All of this is sort of like looking like we're just going down the rabbit hole. Like, what are we doing here? We got this much T. The thing is, W is alone. So this is what we've got for W. All right. Therefore, if we want to find D, we can go back to either equation, and the first one looks easier. So we take that, and then we're going to replace W with this crazy madness. All right. As you can see, the 7 and the minus 2 will combine to make 5. So we'll rewrite it as D is equal to 2 parentheses. All of this will make 5 plus this big old ugly number with a T in it. And then we'll multiply everything by 2. So D is equal to 10 plus, and then we'll just do 2 times this old ugly thing. So let's take that, put it into Desmos, and it'll be like 2 times that madness. We get this madness, 1.42857142857 you get really used to that weird set of numbers. Anyway, we've got that much t. And you know, the thing is, you can't do anything about it. So W is this, and D is this. I guess the weird thing about this is that as long as you have the t in there, it's not checkable, so I'm just going to go with that. It's not checkable. 3 variables instead of 2. The point being, and this is really the whole thing that they're trying to teach you, is that you can't solve a 3 variable system like this. You can only solve 2 variable systems like this, not 3. And that, you know, that's shown by the fact that we could never get rid of the t. And that's the point of that problem. Okay, F. This one's going to be elimination. As we talked about before, if we multiply this entire equation by 2, we'll get a coefficient of -6 on the x, and that will drop the x's out. So I'm just going to do 2 times this business, make it red to show that it's my work. And that's going to give me that positive 6x that I'm looking for. So it's going to be 2 times 3x, which is 6x, minus 2 times y, so minus 2y is equal to -2 times -38 is -76. So we've got this right here, and we're going to put that, and then we're going to be like, well, here's our other equation, and we are going to say plus this equation, and this equation we are going to both underline and make red to make the whole thing pretty easy, and then we'll undo the underline and check out what happens. 6x plus -6x is 0. -2y plus 2y is 0. And -76 plus 76 is 0. So that's 0 plus 0 equals 0. I think that's a true statement. So then that would be all real numbers. Remember that? Remember that? It was like whenever you get a true statement, it's true for all real numbers. So what should happen actually when we graph these two equations here, what's it going to look like? We have all real numbers. So we already saw when there was no solution. What will it look like when it's all real numbers? Well, let's take a look here. We're going to do that, and of course that ends right there, so we'll get rid of that. We'll put that one. Do we have an equation here? Do we have, there it is. Okay, there is a line. And then we get rid of the thing, and ooh, the line changed color. I think the line changed color because they're actually the same line. That makes sense. In other words, these two lines have exactly the same solutions all the way along. That's what it means for it to be all real numbers. Whoa, Einstein stuff right there. So the solution is all real numbers. And my solution is correct, even though my spelling of correct is predictably not correct, because I'm hella. Dun, dun, dun. Yeah. All right, let's look at G. Chosen method, elimination. We saw a way to make this disappear against this, and I think that's true if we multiply this entire equation by 3. We will get a positive 9y, which will disappear against that. So that looks like the way to go. So the first thing we'll do is multiply that by 3. Hopefully you're getting used to this concept at this point. When we do 3 times 5x, it becomes 15x. 3 times 3y is plus 9y. And then equals, and then 3 times -6 is -18. So then we have this equation. Oh, okay. That was just an arrow. Boy, that was weird. Okay, sorry, that was supposed to be an arrow. All right, so then of course we'll just add that to the other equation, which will of course make the y's disappear. At least that's what it's supposed to do. All right, we don't need that h. You go away, you h. You don't belong there. All right, we'll underline and make that red to show that we are adding. And then let's add this together. 15x plus 2x is 17x. Positive 9y plus negative 9y is just plus 0. And then negative 18 plus 18 is 0. All right, so then get rid of the 0. 17x equals 0. Guess what? I'm pretty sure if 17x is 0, then x is 0. And if x is 0, we can plug it into either one of these equations and find y. I'm going to take the first one. We're going to replace the x here with 0 because we know the x is 0, and we're going to use that to find y. Okay, make it red to show it's our work. 5 times 0 is 0, so 0 plus 3y equals negative 6. Therefore, 3y equals negative 6. So if we divide by 3 on both sides, y equals negative 2. So we should get a solution of x is 0, comma, negative 2. Let's take a look in Desmos to see how good our work is working. You two are old, you go away. Here's the new one. Whoops. Cut. There's one line. And when we get rid of this, we'll see it intersects at 0, negative 2. Is that familiar? Is that correct? Is that familiar? Is that correct? 0, negative 2. My solution is correct. Woohoo! All right. We've only got one left, and it's going to be h. Here, h says x minus 3 equals y, and then 2 times x minus 3 minus y equals 7. I see this x minus 3, and I notice it's showing up here. So instead of writing x minus 3, I'm going to write y right there. I'm going to substitute y in where I see x minus 3. So I'm going to write this equation, and I'm going to replace this x minus 3 with a y because I know it's equal to y. And then I can solve for y. So 2 times y is 2y, minus y is y. So y equals 7. Oh, that was easy. All right, so let's take that y and put it into here. I could choose either equation, so let's put it into here. I see x minus 3 equals y, so x minus 3 equals 7. So then we'll add 3 to both sides. We'll add 3 to both sides, and we'll get, adding 3 to both sides, we'll get x is equal to 10. So our solution should be 10, comma 7. All right, that sounds plausible. Let's check our work. Hello, Desmos. Fancy meeting you here. Get rid of this stuff. Go away. All right, come back. You're welcome. Where they cross? Where they cross? They cross at 10-7. What did I say? They cross at 10-7. Oh yeah. And I spelled correctly.